Hey guys, how you doing? And welcome back to Purple Wave Chemistry. Coach Scott again. And as you can see right here, we're going to go to our next little thing on bonding. And we're talking about molecules now. Things that are mostly made up of non-metals, right? So we're talking about covalent bonding. And we're going to do something called a Lewis structure. Now, what these suckers are, all right, are two-dimensional, so in other words, they're flat, representations of the molecule. I can't spell. Representations of the molecule, whatever it may be. Uh, the key thing when we draw most of these Lewis structures is to apply the octet rule, or the rule of eight. All right. So these molecules, atoms, are going to share the electrons to where they can get eight valence electrons around each of the atoms, with few exceptions. And of course, there are exceptions to every rule, right? We're going to talk about some of those too. So, first, we want to do the skeletal nature of the molecule. Or what are we talking about? What atoms are we talking about? All right. So, we're going to find which of these atoms are bonded to the central atom. All right. Using at least a single bond, which would be a dash or two electrons. Now, usually the central atom is the first atom in the chemical formula. All right. So if we're talking about carbon disulfide or carbon CS2, then the first one would be the carbon. So that would be the first atom we're dealing with, right? If we're talking about carbon tetrahydride, CH4, or methane, all right, the first one would be the carbon. Sulfur hexachloride, CCl6 or SCl6, the first one would be the sulfur. All right. So we're going to start with the first atom in there. I've got some samples right here. Okay. And so, I don't know, let's start with sulfur sulfur tetrafluoride. So the molecular formula for that would be SF4, sulfur tetrafluoride. So our first central atom would be sulfur. So I'm going to draw that in the middle. Okay. So that's going to be my central atom. Now, if I've got two or more central atoms, all right, usually the central atom is going to be the least electronegative. So now I'm going to draw the other atoms, more electronegative, I guess you would say, the fluorines around it. And of course, they're going to be at least a single bond to there. I'm going to use the two electron dots right now. Yeah, and then we're going to now we're going to make sure that we have the proper number of electrons around our sulfur. Now, sulfur, I believe, sulfur is got 6 electrons around it. All right, I'm going to make these blue. All right, so there's 4. So I've got 2 more somewhere. Now fluorine, so we're going to have to do 2 right there. Fluorine has 7. Make those green so you can see those. Boom, 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 boom. So that has an octet. this as an octet. All right, so each of those has that, right? Um, Now, of course, we've got to make sure that we have the right number of electrons. So fluorine is in group 17. That means it's got 7 valence electrons. I got 4 fluorines. So I'm going to do a little multiplication. 4 times 7 is 28. And of course, sulfur is in group, I'm going to say that's for fluorine. Sulfur is in group 16, so it has sulfur. It has 6. Get rid of that. 6. So I should have 34 electrons. I've got to deal with 34 electrons. Okay? So we got that. So, don't have those yet. So, I've got 8 there, 8 there, 8 there, and 8 there. I've got 8, 8, including the ones that are sharing. I got 8 there and 8 there. So that's what? A total of 32 electrons. That's E minus. Make sure you can see this one. 32 electrons. Supposed to have 34. If I don't have those, so what I can do, or what may happen, all right, all we've got to do, we need 2 more. So the sulfur will have 2 extra electrons. Now what that means is there's a lone pair, a bonding side, right? So that's it. If I want to clean this up a little bit, I will. I'm going to make lines for my sure you can see that. Give this up a little bit. Whoops. Fluoride right there, fluoride right there. Now, those lines mean there's a pair of electrons. So I'm going to put these electrons, or the free electrons, around it. The free pair. All right, so if I add all those up, those are 32. We should have 34. So that means there's another pair of electrons right there. Okay, that'll come into play later. Something we call VSEPR. We're not there yet. So that means there could be another. We could add another 2 fluorines there. Things to be weird. So, of course, they were talking about molecules, which are a little different. Now, there's exceptions to everything with the octet rule. Okay, we'll work through some of those. Let's look at another one. Let's look at carbon dioxide, CO2. Okay, so our central atom be the least electronegative, or carbon. Okay, put that there in the center. Now let's see how many electrons, valence electrons, we're dealing with. Carbon, there's one of those, and it has 4 valence electrons. There's 4. Oxygen, there's 2 of those, and of course it's in group 16, so it has 6 valence electrons, or 12 total. So that means we've got to deal with 16 valence electrons. Okay, so let's put our two carbons there and our oxygens. Okay. Now let's see. Let's put an octet there. Okay, let's see. I got 2, 4, 6, 8, 10. All right. 12, 13, 14, 16. I've got 8. There's the 6 of oxygen. They're sharing those 2 electrons. Those are the 8, 6 from oxygen, 2 from carbon. And let's see, we've got 8, we've got 16 electrons. So that's what carbon looks like, carbon dioxide. Clean that up with lines. That means there's no electrons around the carbon, just those 2 that the 4 that it's sharing. But let's see if this makes sense. Okay, I've got 2, 4, 2, 4. I've got 4 carbons there. I've got to have an octet. Missing 2. So let's take these 2 and these 2 and move those there. Let's do them up here first. All right, so now that is, you got 8 around the oxygen, 8 around the carbon, and then of course now we've got 8 around the carbon. So let's clean that up some. Get this where you can see it. And I'll come back and do some more with these. So let's see, carbon. So that means there's 4 electrons bonding it to this one oxygen. That leaves the other 2. There's 4 there bonding it to the carbon. And that means it's got 4 left. So let's see, do we have 16 electrons? I've got 8 electrons there, 8 electrons there. Everybody has their octet. All right, so we're using the 16. So this would be the structure for the carbon. We'll come back and do some more. All right, so Coach Scott, see you guys in a bit.